I'm Vladimir Vinogradsky. I look after API management. I've been in API space for about 5 years now. Started with Epiphany, a company that was acquired by Microsoft where API management came from, and been doing it sort of since then and enjoying it. My presentation today is essentially for the next 40 minutes, whatever we have. The plan is to try and explain API management to you guys. And by the way, can you just quickly show of hands, who is familiar with API management already? So I'd say probably 15%, so I'm in the right place, great. So I'm gonna basically explain API management, how we think about it, and the value it provides. So perhaps you understand a little better where you can use it. I'm going to try to spend most of my time showing API management in action. If we have time at the end, since we've been sort of in GA, general availability, commercially available for about a year and a half now, I thought I owe you a little bit of a report card of where we are as a service and show you some of the customers that we have. And then answer questions, and if not here, then obviously we can talk afterwards or tomorrow. So with that, let's begin. The rise of APIs. This title seems very appropriate given the graphic. So if I'm going to read the second quote, this is my favorite. APIs play on the front lines of business opportunity, creating new sources of revenue and market presence. They play behind the scenes, unlocking data and transactions buried in back office systems. And they play anywhere in between. Does this resonate? Yeah? It does with me, and frankly, based on the customers that we see and the usage patterns that we see, this is actually very accurate. So the bottom line here is that APIs are becoming sort of more prevalent in the industry. There is a lot more businesses out there starting the API programs and starting sort of to leverage APIs for all these things that I mentioned in this short paragraph. Those APIs becoming more and more important to sort of their publishers. And as they're becoming more important, obviously they need to be cared for, they need to be managed, they need to be protected, they need to be measured, and they need to be harnessed, right? And that's where API management comes in. So the way we think about API management is along these 4 buckets of value, right? Maybe a little bit awkwardly called, named, but I'm going to try sort of to unpack it for you. So first of all is facading, right? So creating a facade, creating an abstraction layer on top of your back-end APIs, right? Whatever they might be. It's a very powerful thing, right? Because level of indirection always comes in handy later on. So what you can do is, for instance, hide the actual sort of some of the capabilities of your backend, right? Expose only the ones that you want publicly accessible. You can also modernize or optimize the backend API, because some of those backend APIs might have been created, 5, 10 years ago, and look complicated, don't look modern. Or even when you bring a bunch of different backend APIs into a single sort of API that you want to project to the public, you want a sort of consistent look and feel. And so you want to change it, right? So you want to create this nice facade over it. In addition, it gives you capability later on, change the implementation without disturbing your clients, which is very important. There are sort of extreme cases of facading, and I'll show you some of them, where essentially you can actually add capabilities to the API which didn't exist before in the original backend. Second set of capabilities are around middleware. So essentially there is a number of cross-cutting concerns that you sort of have to configure on your APIs, be it backend APIs or API management, security, protection, throttling, rate limiting, quotas, caching, logging, lots of things, right? And you can, of course, go and manage it separately in each of the backends, or you can manage them in bulk in one place, which is a lot more convenient, right? And make your backends simpler and make your policies centralized and better managed. Next sort of bucket is monitoring, and this is sort of a broad word, but we think of it as usage health and monetization. So you really need to understand who is using APIs and what APIs are most valuable. Who are your customers? What are your more active customers, right? What are these cohorts of customers that you have? You really need to understand how your API is performing. Are they healthy? Are they throwing a lot of errors? And of course, monetization. You need to measure consumption of your APIs in case you want actually to charge people for using your API. All of these things, again, you have to implement, and API management trying to help with these. And lastly, APIs, the power of APIs, right, is harnessed by developers. So it's sensible to treat them nicely. And regardless of if they're internal or external developers, right? Developers like, to get to the chase very quickly, right? They really need to quickly understand what your API is about, what value it brings to them, how to use it, get onboarded to use it, and then start coding against it, or even maybe playing with it without writing a line of code. So we help with that as well. So this is basically the way we kind of structure, our thinking about API management. Now, we talked about these back-end APIs, so what are they, right? So they can be anything, really. What we see, and we are an Azure service, so naturally we see a lot of APIs on Azure. Azure has lots of ways that you can build and host and run API at scale. We have app service, and there you have API apps and functions, which you can hear more about tomorrow. We have, obviously VMs and things like Service Fabric where you can host your APIs. Second sort of bucket of APIs are actual Azure APIs. We see actually customers trying to expose service bus topics, event hubs, even storage accounts through API management, right? Because you don't want to create this abstraction layer by hand, right, if you want your partners to use it. But it's very handy to be able to actually very quickly expose it securely and simply to consumption. Of course, on-prem APIs, right? A lot of sort of value is on-prem still, and that's another sort of very big sort of cohort of these back-end APIs that we see. And then third-party APIs. This is actually the case where if you are consuming APIs, if your organization is consuming APIs, sometimes you actually want abstraction layer on top of those, right? So that you don't get glued to the implementation, right? So you have that ability to control and facade. So all of these scenarios we see customers doing. And of course, API consumers can range from service to mobile apps. Logic apps, for instance, very interesting, right? Because logic apps essentially consumes APIs, but it also exposes an API. You heard about the HTTP triggers, right? So it can actually play on both sides of API management. So API management really, to paraphrase the ad, it doesn't build your APIs, but it makes your APIs better, right? So essentially API management is a layer on top of your endpoints. And essentially, produces sort of all these capabilities that you otherwise have to sort of build into each of the APIs. So next, let's look at what the architecture is. So obviously, there's back-end APIs, and as I mentioned, they can be hosted anywhere, including Azure, and developed using any technology stack. API management has three components that we're going to sort of talk about. And you're going to see today publisher, developer portal, and the gateway. API management is a cloud service. Basically, it lives in Azure. And it can connect to your backend APIs either directly or using VNet or VPN. So API publishers, people who are actually trying to expose backends for consumption, they use Publisher Portal to configure the APIs, right? So some of these sort of things that publishers do, they register APIs with API management, they configure policies, they look at analytics and do sort of other management operations. They can do them interactively using this Publisher Portal, or they can automate management operations using management REST API that we provide, PowerShell or .NET SDK, if they're so inclined, and very new capability that we recently released is a Git configuration endpoint, where you essentially can use Git toolchain to pull and push configuration of API management into your tenant, and then, of course, version it. The information that the metadata about your APIs, all the configuration that you enter on the publisher portal drives the rest of the components. So essentially, developer portal gets populated with the documentation based on the metadata you entered, as well as gateway is configured through the metadata that you enter through the publisher portal or other management tools. So it's always in sync. Your portal is always in sync with your gateway. There is no deviation there, because they feed from the same set of data. So developers come to the developer portal to discover your APIs, to essentially get to use them in literally a few minutes without writing a line of code using interactive console that is built in. Developer portal is essentially has a bunch of information that we auto-generate based on metadata dynamically, such as API documentation, interactive console, code samples, and things like that. But it's also a CMS, so content management system, where you can actually brand it to reflect the image of your organization, and you can add additional content. You can even subordinate our developer portal to your larger developer portal in such a way that we are used for documentation and API management and live within the broader portal that you might already have. So of course, the whole thing here to have developers build applications, and when they do, those applications access your backend APIs through this facade created in API management. And every request flows through the gateway. And gateway is where the magic happens. That's where the facade, where the translation happens from the public or front-end API into back-end API. This is where protection policies are applied, where security policies are applied. This is where we keep track of things and meter and measure your API. So most of the value in the gateway, or most of the things done in the gateway, are done through policies. Policies are essentially an encapsulations of common API management operations. And you can see some snippet of what those might be. You can apply them at different scopes. So you can apply policy to all APIs in your API management instance, or just APIs that are grouped into a specific product, or just to a single API, or even to a single operation. So you have a choice of managing in bulk or managing very specifically. They can be set, obviously, in the inbound or outbound direction. Inbound is from the client to the back end, and of course, outbound is the opposite. Quite recently, we introduced expressions. So essentially now you can mix those declarative policies with a little bit of imperative C# and dynamically configure those policies, which adds tremendous power to the policy engine. And of course, for security purposes, C#, your expressions have access only to whitelisted .NET types, although it's a pretty broad set of types that we have permitted access to, as well as it only has read-only access to the required context. If you want to mutate, you have to use policies. So in the next few minutes, I'm going to show you the demo that demonstrates all these aspects of API management. I'm going to call them out. So for Facade, I'm going to use two APIs. On one API, I'm going to end an operation, right? Which the API, one API is backed by something that runs in Azure, an API app, essentially. And I'm going to modify a little bit the response that it sends, as well as add an operation to it, which will map to a function. By the way, how many of you guys are familiar with functions? Very few, so you have your work cut out for you tomorrow. So function essentially is a very interesting thing I'm going to show you briefly today. So essentially it's a RESTful endpoint, and I'm going to let Chris explain it in more detail to you. So I will basically aggregate those two things into one. Then in the second example, I'm going to show a little bit more elaborate thing. I'm going to use external API, third-party API, and I'm going to add operation to it which doesn't exist on that API. I'm going to actually sort of manufacture it in front of you here. From the middleware perspective, I'm going to muck a little bit with the throttling, right? I'm going to basically impose some protection limits on this API so that they can't be sort of called too often by customers. I'm going to show you some custom analytics that you can do with API management. And of course, I'm going to show you developer portal, what it looks like. I'm going to show you, hopefully we'll have time to show you a portal that is created by one of our customers, which, as far as I'm concerned, is probably the best portal I've ever seen in terms of how carefully it was built out. And then I'm going to show you some of the new capabilities we added for you to quickly modify the developer portal to make it your own. So with that, let me start switching out of this. Here we go. So this is API management tenant that I created. So don't pay attention to the first two APIs. They're sort of there for me as a safety net. But I'm going to work with the two below. I'm going to start with the conference API. So let's go to the developer portal and see what we can do with it. So in the developer portal, this is basically what it looks out of the box, right? So it's fairly basic, and it sort of uses Microsoft look and feel, but again, you can customize it any way you want to. So let's go to Conference API and see what it does. As the name implies, it has some operations here for sessions, speakers, topics, sort of very, very easy to understand kind of thing. Sessions get is a very simple function. I'm going to just try calling it right here. And again, all I did was import this thing, using Swagger into API management, and I immediately have documentation. I have interactive experience over it. So here I'm going to go and just send this request. It comes in, and there is some result there. So as you can see, we have this little URL here. If you open it up, you actually will see everything that is done in the gateway. Right? So this basically gives you full information about what is going on the gateway. And as you can see, here we have this, oops, sorry about that. So we have this forward request policy, right, that basically forwards request onto the backend. And you can see that the request goes to this URL on Azure websites, which is essentially a domain name of that the app service uses. So let's go and look at that guy. Here it is. Same URL. So this is an API app on app service. App service is a great way to sort of host your APIs. This API has a description in Swagger format. And essentially, what I did was I imported this URL, or rather description of this API, this URL into API management to get it there. So if we go back here, we notice a few things that we want to change. So first of all, as you can see now, that this API actually is available at a different URL, right, at this front-end URL of your API management instance. So if you go down here, you will see that the actual API app is producing references to itself, right? Because it's unaware that there is something in front of it. So we definitely want to change that because we want, again, everything is routed through us. Second of all, it releases a bunch of information about what's actually is running on the back end, and we probably don't want to have that. And of course, this Pragma no cache is very outdated, and we can strip it as well. And of course, now I can actually issue as many calls as I want to this API, and that's probably not a good idea either, so we want to put some throttling on it. So let's go and do that. And I'm going to just go back to manage. And the reason I can do it is because I'm an admin. And I'm going to go into policies, and first I'm going to configure policy to just deal with the issues I just described, right? So in this case, I'm going to apply policy at the API level to the whole API, so it applies to all the operations there. And I'm going to just put it in here. And I created a few text expansions to speed things up. And I think that is the one. So basically, it's just a bit of XML. And the policies themselves, you can sort of drop them in by clicking these buttons. But again, for to save time, I did the text expansion here. So first of all, in the inbound section, you see that I'm rate limiting, right? And I'm rate limiting to 3 calls per 10 seconds, so remember that. And as you can see, I have a counter key variable that I use expression to assign IP address for. So you can use anything, right? And based on what you use there, the behavior will change, right? So if if IP address is a good representation of your clients, then that's a good thing you can sort of throttle on. Or you can throttle on a combination of header values, for instance. Or you can throttle on the URL itself, for instance, for backend, right? It's also available in the context. And that way you're going to protect backend from spikes in traffic, right? So again, very flexible policy, allowing you, depending upon what you throttle on, project different behaviors. So that's one thing. In the outbound, right, I want to clean this stuff that I noticed, right? So first of all, I'm doing find and replace, obviously to sort of rewrite URLs. Then I'm deleting a bunch of headers. And then I'm setting a header here to time elapsed using the variable I saved up there in inbound, right? So very simple. So let's just save that. Exit here. And go to the developer portal. Let's go back to the API. We'll use the same operation. Okay, here. So let's make a call. And you can see that, first of all the, of course, headers are gone. There's time elapsed right there, second. And then, of course, all the URLs now pointing neatly to the API management, right? So very simple, with just a few lines of code, I rewrote the behavior, right? So now let's go and add this operation I was talking about. So for that, I'm going to go back to management, go into the API, and again, I could do this using REST API, but I'm going to just do it, using interactive approach here. So I'm going to do add operation. Operation is essentially has a name, so we should. What is it? The operation I'm adding, by the way, one important thing I neglected to mention is that I want to add operation to get rating for a session, right? So I have session speakers, etc., but I want to add this operation to my API. So I did this. I'm going to put a little bit of a description. It's going to be a get operation. I'm going to put a sort of URL template, the way I want to expose it to the public, as a front-end API. And as you can see, it sort of fits the pattern that all my other operations have. And I'm going to add rewrite over here. So why is this rewrite here? Well, because the way I'm going to implement this particular operation is by using a function. So let's say my developers decided that they now want to adopt microservices approach, and every collection there will be represented by its own microservice, and they decided to use functions for it. Okay, so we're going to go into this function app. And again, Chris will open up tomorrow with discussion of functions. They're really cool and really easy to create. So here I have this get rating function, and essentially it is triggered by an HTTP request and produces an HTTP response. I used C#, but you can also use Node.js and in the future other languages. And essentially what it does here, it pulls a connection string and connects to the database and reads the value based from the database based on this session ID variable it pulls out of the request, right? So, and you notice the this is the URL, right? And it has code, which is basically a key in it. And that's what I use here, right? I'm basically rewriting to point there, right? So we can also define parameters. I'm going to use number here for session ID, and I'm going to create a default value, okay, and save it. So now we have a new operation. So if I go back to the developer portal and refresh, I should immediately see it, because again, it just fits from the same data, and sure enough, I have that. So if I call now, right, what's going to happen is 404, right, because API app, which now all the requests are routed to, is completely unaware that this operation exists, right? It doesn't implement it. So I need to actually start routing to a different place, because this API has this default backend URL for the API app. Now I need to reroute this specific operation to something else. And of course, I do it with a policy. So let me go back over here into policies and select conference API and get ratings by session operation. And here you see a dirty little secret that actually rewrite is also a policy, right? And here I will insert a few other things here. Basically, I'll rewrite method from get to post, and I'm going to set backend to this function backend URL, right? Very simple. So let's save this guy and try again. And all of a sudden it started working. You saw a little delay there in propagating information to the proxy, but as soon as the propagation happened, now I'm getting this 88. I don't know if it's good or not, but basically that's the value in the database. It's fetched by the function. So now my API, my front-end API, some operations go to API app, some operations go to the function, and tomorrow I might change my mind and switch it, right? And my client will never know the difference. So what's interesting too, by the way, is since the throttling policy is applied to the API, not to the operation, right? It actually still affects the this operation. You don't see the headers that were removed, right? And also you see that throttling still applies, right? So throttling is still enabled and protects that operation as well. So that's pretty cool. So let's see if we can do something even more interesting. So with this, I'm going to go and manipulate a different API, which is this other guy over here, which I call local weather. And sort of this local weather API, and this is, by the way, let along of where we are right now, it essentially gets local forecast for that particular location described by latitude to longitude. So let's make a call here, and it gives you basically the temperature that we're enjoying right now. So if we go and actually look at, I don't know if you guys enjoying this weather or not, but I'm from Seattle. That's normal weather. So, so this is basically again, the trace output shows you what's going on. And as you can see here, we're actually forwarding, the actual implementation of this API resides with API forecast.io, a very nice little API out there that is behind this dark sky API application that tells you like when rain starts and stops and things like that. Really awesome. So I basically subscribe, they have some free tiers, so I'm using that just for demonstration purposes here, but you see that it goes to this API forecast. What's interesting thing about this API, it has just one operation, I'm using it. So it always needs let long, right? What if I want to expose to my customers ability to actually use postal codes, let's say, or even maybe address? I'm not going to do that, but I'm going to do postal codes. So let's go into APIs here, go to local weather, And frankly, I'm running, so it's 4:30, right? My session ends. So I'm probably not going to be able to do the demo live here, but I'm going to, that's why I had these guys over here. So let me show what actually happens. So I'm going to go to this final guy and show you that I added an operation, get weather by postal code, right? So this operation essentially exposes this particular, is exposed at this particular URL. As you can see, it takes postal code in. There is no rewrite, right? It basically says here that there is dynamic rewrite somewhere in the policy. And we're going to go and open that policy. And we're going to see a bunch of stuff here. So first off, as you can see, I have this wonderful send request policy set, right? So with that, I'm actually doing lookup and map postal code to Latin long. And I'm using Google here, but I can easily use Bing as well, right? So it's a very simple lookup. Then I'm using the information that I retrieved, the Latin long, to rewrite and send to the forecast API the data that it expects, right? So to make it work. So I'm still using forecast API as my backend, but I'm doing this data transformation from postal code to Latin long right inside the proxy. Doing it on every request would be a little inefficient, right? And in this particular example, postal codes don't change locations very often. So it's pretty safe to cache them. So what I'm going to do here is I'm going to actually first, of course, store the retrieved value in cache. And then I'm going to add a lookup of that value. And so I'm basically looking up postal code right in my cache. And if I didn't find it, only then I'm going to issue send a request. And so what happens really is that every time that I come in, if there's a new zip code, first time, I'm going to go and actually do the mapping, and then I'm going to store the mapping and reuse it from that point on. So very simple. And I'm going to talk about log to event hub in a moment. So let's cancel out from here. Let's go to this guy. And I hope it still works. So here's weather by postal code. Let's do try it. And I don't know, let's do Helsinki. Bam, right? Still works. So essentially my policy converts, caches, and then fetches information from forecast.io. So a little bit different, a little bit more complicated, but still very doable. So now let's talk a little bit about monitoring, right? The analytics. So we do provide some out of the box. So if you come here, you will see that we have a bunch of graphs here. If you go to usage, you can see that we can actually look at data over periods of time, and you can actually even select what you want to see. And if I'm going to go and see, for instance, a local weather, right, I'm going to see basically my calls to it, etc. But I don't know anything about those calls. These are just requests to me. Like, what if I want to see how many calls were made for each zip code, right? Maybe I want to know which zip code is particularly popular, right? I cannot do it here because this basically is reports that we provide, right? And they are very generic. So what if I want to do this custom report? Well, for that, we actually just recently released this interesting policy, which we call log to event hub. And you guys probably familiar with event hub. If not, I'm sure tomorrow there will be a lot of conversations about that. It's a great way to actually send and receive events, very scalable, very durable. So here we have sort of our typical scenario where requests flow through API management. But what if I will take this log to event policy and siphon some of that data on each request or selectively, whatever format I want to choose, and whatever data I want to send to an event hub. Well, then from event hub, actually using out-of-the-box integration, I can consume it with Stream Analytics and put it in Power BI. I can easily use Stream Analytics right directly with Event Hub, put data into Data Lake, and then analyze it with Data Lake cluster. Oops. I can use functions, right, to store data in the SQL database and then run machine learning on top of it. Or I can kick off Logic Apps workflow, right, because they also can receive events or kick off sort of workflows based on events in the Event Hub. So that's what I'm going to do here, but I'm going to actually show just this scenario, but I'm just showing you that the services in Azure, right, there is this critical technologies, they make things kind of click together, right? And this is one of them. So let me go back and show you this policy. It's actually not much to look at, to be frank with you, but it's very, very powerful, and I'm going to show you the result as well. So if I'm going to go to local weather final, I think it's this guy. No, actually, it will be just for this operation. And go full screen, you see that I have this log to Event Hub policy right there at the bottom. And essentially, again, I'm using the let and long information, and then I'm gonna basically, I'm using CSV format here, so I create basically a string containing first line, first row of that sort of will be basically labels, and the other one will contain some information. I'm using current time, request ID, IP address, operation name. And importantly, I'm using postal code as well. So postal code now is logged along this information into Event Hub, where it's picked up by this streaming job, which shells it into Power BI. And I can actually now very easily get reports like this, right, which show you not only aggregate traffic, and of course, this is a synthetic test, so it looks kind of very neat and even, but you get the point, right? So I have now traffic over time by zip code, right? And the legend is up top. Not only that, I can have awesome map like this, right? Which actually shows me which zip codes were looked at, and by the size of the circle, I can see which ones are more popular. So all of that was just this one Event Hub policy and a bunch of other sort of complementary Azure services. So it's pretty cool how we can basically now take and extend the reports that we provide out of the box very easily with other tools that we have. So I'm going to show you a little bit of a so you saw the portal as it looks out of the box. Here is the company called Blackbaud. These guys are sort of probably biggest provider of software to nonprofit organizations. They have software that deals with fundraising, and things like that. They operate in 30 countries in the world. Really, really interesting company. And they've been working on the API program for a long time. And this is the result, right? So you can see that it looks very professional, looks very neat, reflects the identity. Look at what they did with the APIs. They changed all the labels, of course, right? And this is what their API documentation looks like. So completely changed the look and feel of the portal. So that's basically what you can do as well, right? We just provide you with raw tools. But if you care enough, right, there is basically unlimited possibilities in how great it can look. So let me go back to my presentation and finish with a few slides so I don't hold you guys up. So let's see here. So I'm not gonna spend a lot of time doing this. All right, here we go. So this is a report card. So I like the two numbers at the bottom, right? These are annual growth in calls and number of customers. So we're seeing a lot of people picking it up. And the growth in calls is especially interesting because it outpaces customers, and it means that customers are actually starting to go into production and the API programs becoming more popular, right? So this is a very good sign that things are sort of looking up and working well. We are actually in 20 regions. I was told that yesterday we lit up in Canada, in 2 data centers. I don't know if we have customers there. That's why I'm conservatively saying that we have customers in 18 regions and not 20. I have a few slides here, and I'm sure slide decks will be available of a few customers we did customer stories with recently. This customer is a SaaS services provider, and these guys build applications for hospitality industry, so they're opening new business models with exposing APIs and monetizing them directly. Sonoma is a big media conglomerate in Europe. These guys basically are pioneers in digital. As you see, they went digital in 1996, which is pretty early. And now they're sort of leading the way with exposing APIs to be more agile and build new products, new media products faster. This customer is especially dear to me because these guys were our first customer at Epiphany. They're still with us. If you are into sports, in fantasy sports specifically, they've got the data. And that data is exposed through APIs, and that's the only product they have. And it's just a few guys, right? So we go from huge companies to small companies, and all of them benefit from APIs. We have a few notable customers at Microsoft. We have actually a lot of Microsoft internal customers, but these are sort of the ones that probably you're going to recognize. Again, if you're a gamer, Halo. And this customer is a very interesting one, Cognitive Services. These guys have terrific APIs based on machine intelligence for video, audio, text analysis, so really cool. Sort of all of them use API management. They use our portal. They use our gateway. So they're great users. So takeaways. APIs are building blocks of modern apps, really, right? So software runs on APIs these days. APIs need to be managed and protected and cared for. And don't forget the developers. Developers are key to actually harnessing the APIs. And of course, API management is a necessity, and M is a small m because it's basically a discipline of API management, right? There's a lot of evidence that build is better. Buy is better than build. So that's basically my message to you. So if you enjoyed it and you think that API management could be useful to you, we have a few things that you can do. First of all, try it. We definitely thrive on feedback from customers, so we have a user voice page where you can submit your ideas, feedback, wishes, etc. We recently published a frequently asked questions page with a lot of sort of common questions that customers ask us. So if you have burning question, check that out. We issue updates on our documentation page. There's a running feed. You can subscribe to it. And of course, we also follow with announcements on Azure API Management Twitter feed. So with that, thank you very much for your attention and enjoy the rest of the conference.